Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad ZAKWAN bin FAWZI, and I would like to present our group projects for Foundation Engineering. And we are from Group 3. This is our company. Our company is called Magenta Construction. And on the right side is our organizational chart, where AIDIL AKMAL as a project director, me, Muhammad ZAKWAN, as a geotechnical engineer, Nur HAZWANI as a structural engineer, Muhammad Danial Fakhri as a project manager, and Muhammad ALIYUDDIN as a construction engineer. Okay, so this is our project that we are currently working on. Our project title is called The Development of Two-Story Bungalow House at Taman Sepadu, Glugor, Pulau Pinang. And the duration of the project is from 12th of July 2019 until 8th of August 2020. So our project is done, but this is our report. So our responsibility is to design a suitable foundation for the building. So on the right side here you can see the drawing of the bungalow. So for the analysis of soil investigation, we have conducted a soil investigation at the middle of the bungalow house. So this is the borelog from borehole 1. So from this soil investigation, from this borelog, we know that the surface layer of the soil consists of loose sand with a very low N value until the depth of 6 meters. So from here we can conclude that the shallow foundation cannot be used since the surface soil is very weak to support loads from building. So we suggest that we use a deep foundation so that it can transfer load from building to a much stronger layer which starts from 6 meters and below. So for soil properties from borehole 1, on the left side is the borelog from borehole 1. On the right side is the calculated soil properties. So we have the N value, the N60, friction angle, and also unit weight of the soil. So this is how we calculate the N60. From the borehole 1 depth of 1.5 until 3 meters, we have the N value of 8. So just plug in the formula and we will get the N60 of 7.8. So for the friction angle, also from the same depth, we have the N60 of 7.8. Just plug in the formula and we will get the friction angle of 29.41. For the unit weight, also from the same depth, N60 of 7.8, just use this formula and calculate. We will get 17.97 as the unit weight of this soil. So for loads from column, on the left hand side is the structural drawing of the bungalow. So we analyze the building using STEAM, and this is the axial load for each column. So from this axial load, we have classified into two groups, which has an axial load range of 300 until 550 as a group A, while 550 until 750 for group B. So for group A, we have the ultimate axial load for 413.6. For group B, we have 715.3 kilonewton as the ultimate axial load. So from this figure below is the position for each pile for each group. So yellow is the group A and blue is for group B. So from this figure we know that the lower axial load resides on the edge of the building, while the column with higher loads is located near the middle of the building and also on the side of the building. So this is all from me. Thank you.
Assalamualaikum and a very good day. My name is Nur HAZWANI binti HOSSAIN, and I will present the calculation part. In the calculation of the load bearing capacity, we had decided to use the Meyerhof method, and the formula that we had used for this calculation is shown in the slide. For group S load carrying capacity, which is the QP, we had gained 609 kilonewton. And for the ultimate load carrying capacity, which is the QU, we had obtained 536.32 kilonewton. While for the group B load carrying capacity, which is the QP, we had gained 762.4 kilonewton, and the ultimate load carrying capacity for the group B is 776.48 kilonewton. For the calculation of settlement analysis, The formula that we had used for this calculation is shown in the slide, where SE1 represent the elastic settlement of pile, SE2 settlement of pile caused by load at the pile tip, and SE3 settlement of pile caused by the load transmitted along the pile shaft. For the group A, the value for the settlement that we had calculated is 15.27 mm, while the settlement analysis value for group B is 19.73 mm.
Hello, Assalamualaikum. My name is AKMAL and I will explain to you about our result and discussion. So basically, this is what our plan will look like in 3D, and we get this design plan from STM software that we planned. So for the design summary, there's a total of 11 columns in this design, and the calculation was made both by STM software and manually by our groups. So the columns are divided into two groups, which is group A and group B. For the group A, the range of engine load are 300 to 550 kN, while for the group B is 550 kN to 750 kN. This was made to make the calculation easy. So for the pile design summary, as you can see, there's a total of 11 columns, and for group A we got 5, while for the group B we got 6 columns. Okay, there is ultimate engine load, estimate pile size, and frictional resistance, and lastly is the ultimate load carrying capacity. This was made by using STM software and manually calculated. So for the settlement checking, this was checked by our group also by doing some manual calculation. Okay, and as you can see here, the settlement and the settlement check is okay for group A and group B, which range from 300 to 750 km. So special consideration in construction. So structure are supported by foundation, which distribute the load to layer of rock or soil with the necessary settlement characteristic and bearing capacity. So there is no standard depth for foundation, and there is no easy way to figure out what depth are appropriate. Instead, there is a huge variety of foundation type and depths that are ideal for various purposes, based on factors such as ground condition, nature of load requiring support, and space availability. The next is the soil settlement. After a foundation is put in place, the soil may settle. So settlement happens as the volume of saturated soil gradually decreases over time. So if the foundation is built on loose soil, there is a chance that it will progressively settle over time. So to ensure that load will negatively affect the soil ability to settle, a geotechnical engineer must assess the bearing capacity of the soil. The soil must be compacted to the level advised by the geotechnical report prior to foundation installation. Okay, so next is soil erosion. So soil erosion, the footing for structure near moving water must be placed at a depth where score or erosion won't undercut the soil and compromise the foundation design. Okay, so this also holds true for retaining wall, bases, abutment, and bridge piers. So for the conclusion, the weeping tile should be put in at the bottom of the foundation to achieve this. Okay, and next is lastly is foundation in sand and silt. So the loss of density and bearing ability will cause the soil to spill out from the footing perimeter if it is not contained. So sand and or silt that is too close to the ground surface will be more easily eroded by wind and water. So what we have to do is a densification of the loose soil before the installation is necessary for foundation constructed in sand and silt. The footing foundation soil need to be concrete. Okay, that's all from me. Thank you.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Danial Fakhri bin Abdul Aziz, metric number CF200168. Now I'm going to present to you our discussion of this group project. Okay, first thing first, columns are very important for carrying loads from roof beams to foundations. So by doing manual calculations, the critical load of the column obtained is 715.3 kilonewtons. Okay, for this structure, a deep foundation on which the piles were spread was chosen due to its sufficient and appropriate to support the proposed structure. So, at the depth below the structure, there is a hard soil layer which is Group B, with a value of friction angle 3 degree, and indicating that the strength of the soil can support the load of the structure. Calculations of ultimate point QP of deep foundations from Meyerhoff's method was done. So the end values from the calculation of the method proposed shows a fairly significant difference. This mainly due to the angle of friction value of the supporting soil that is high and cause the soil friction and Q such of pile or for Meyerhoff's method to be at great difference. The value of Q, which is 413.6 until 715.3 kilonewtons from Meyerhoff's method, was used in this design for a better safety factor of 3. Okay, this is important to consider the safety factor in designing a structure to ensure that the structure is much stronger than it is intended to build to withstand any unexpected loads or emergency situations. Okay, next. The settlement check for Group A and Group B are both good and passed and do not need to redesign the type of pile. Okay, last but not least, despite the fact that choosing a pile type foundation is more expensive, the safety of the buildings and inhabitants is assured, whereas structural repairs are normally expensive if they are damaged and the safety is not guaranteed. That's all from me. Thank you.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today I would like to present the conclusion of my project. So in this project, we may infer that the soil attributes are suitable for developing a deep foundation based on the information from the borehole and soil profiles. According to the data from the borehole, the topsoil and value is incredibly low and indicates a loose soil type. The deep foundation are structural elements that can be used to transport loads from weak and compressible soils to a stronger layer. So the next one is, based on the structure analysis, we create two groups for the foundation design. The QU for Group A is 586.32 kilonewtons, whereas the QU of Group B is 776.48 kilonewton. And additionally, the rates of the settlements for these soil types are moderate and settlement does not occur often. The results are 15.27 mm and 19.73 mm when the settlement is smaller than 25 mm. Building a deep foundation is more expensive and challenging than building a shallow foundation. However, when dealing with poor soil conditions at shallow depths, substantial design loads and site constraints, a deep foundation is frequently the best choice. And due to this problem, we suggest applying a soil improvement and ground modification. Several soil improvement methods such as prefabricated vertical drains, sand drains and stone columns can be used to control the groundwater table. And lastly, through working on this project, we gained a lot of knowledge, including the ability to read and interpret log data, and we also use the information that we learned in class into this project. The most suitable foundation and the quantity of soil settlement brought on by foundation loads were successfully identified by this study. So that's all from me, and thank you. Assalamualaikum warahmatullahi wabarakatuh.